Welcome back. Hope you enjoyed your lunch. With a show of hands, who here is a back-end developer? Okay, good crowd. Front-end developer? Yay. Full stack? A few. DevOps? Too little. Okay. I think front-end and back-end are going to be acknowledging the fact that with your peers from the other camp, so to speak, you have been most likely debating and talking about challenges with what's the subject of the next presentation, APIs. It's my pleasure to welcome on our stage today, Rodger. I had also the pleasure to introduce him on the first edition of the developers in person, because he was also attending a live one during the pandemic. So, while we wait for others to join us, please join me in welcoming Richard to our stage. I guess Richard is still waiting for the headset? Yes, okay. Just a second, and we'll have him here. You guys enjoying the developer so far? I'm not convinced. Okay, maybe after another coffee break. Okay, Richard,
cool.
Stage is yours.
Thank you. Thanks. Is that working? Okay, cool. Hey, everybody. Hello. How are you doing? I am really pleased to be back in Cluj, and I also have to say thank you very much to Ovidiu, our wonderful organizer. You see this lovely picture? There's no gray hair. You see all the gray hair? This is 10 years of microservices. So, okay. So this talk is a really opinionated talk. It's about a one-size-fits-all solution. It's about doing things one way, and you see a nail and you have a hammer and you just hit the nail. So I'm not going to say this is the way you should solve your problems with APIs, but it has worked really well for us, and I think you can find a little bit of inspiration. So the problem that I experienced in a number of our recent client projects was too many APIs. So who here has built an API, an external API? Okay, cool. So that's fun. That's the easy part in some ways. The problem I'm talking about here is the other side, where you are the client. You as the developer have to use other people's APIs, external APIs. The last project that I was involved in, we had 15 external APIs, and not all at the start, right? The client would ask us, oh, integrate with this, please. Integrate with this other thing. Oh, we have a better rate with this service provider. Change the API from this one to the other one. So I've noticed this is becoming more of an issue with development of client projects, is that there's more and more external services to integrate with. And the problem is, you have to read all the documentation, you have to understand how the SDKs work, all that sort of stuff, and it's too much accidental detail. So this is what we would all really like to be working with, right? Stripe. Who's worked with Stripe? Anybody worked with Stripe, the payment system? If you go to their website and their documentation, it's really wonderful. In fact, I would say Stripe became really successful because their developer documentation was really good. It's just designed by developers for developers. There's lots of examples. It's really well put together. It's easy to see what you want to do and what you want to understand. But it doesn't solve one problem, which is that there's still a lot of details, right? If you want to start using the Stripe payment APIs, you still have to read about, okay, how do I get started? Where do I get my keys from? Is there a developer portal? Do I have to log in? which SDK do I use? How do I set that up? Which versions are compatible with what? What exact method calls do I call? What are the parameters? All that stuff. There's just so many details. Now multiply that by 15, and you end up in a situation where the developers on the team are spending too much time just reading documentation like this, and this is as good as it gets. A lot of the time, it's really bad. It's like auto-generated from Swagger or something, and there's no support forms, and there's nothing. This is a sample I took from a recent project of just a couple of the APIs that we integrated with, and I just analyzed them on a number of criteria, right? So, were they using key authentication versus some other, what I would call fun authentication mechanism, right? Where you might have refresh tokens or something you have to manage. Whether they had an SDK or not, whether they had code examples. So if you have to integrate with an API from a domain-specific service provider, I'm not going to name any names, right? But for example, the consumer rewards industry, right? There's loads of different companies that provide electronic coupons as rewards for consumers that might be using your service. It's a specialized API, it's a specialized domain. They just give you the docs, and there's no example code, and good luck. Whether there's support. So one of these APIs, every customer got their own Slack channel. So we had a personal Slack channel that we could ask the developers of the API provider if we had problems. It was amazing, it was wonderful. Sometimes you get a shared Slack channel, which is not as good because you can't ask questions that breach client confidentiality, but you can still have a little bit of a discussion. Sometimes there's just no support. And then I have this last one, weird, where does the API do weird stuff? Just, I don't know, like it's a JavaScript API, but it was written by back-end developers, and it doesn't really fit the way that JavaScript works. There's too many classes. It's just a bit strange. So you have to overcome that sort of thing. Often with companies, you'll find that because you have to write an SDK for a whole bunch of different languages, the core language of the developers of that company might be C# or might be Java or Go or something. And then they are asked to write SDKs in other languages. So the SDKs end up being weird. So you have all these challenges. This is just some examples. The columns of that spreadsheet could double, right? So this is inefficient. And I felt that we should come up with a way of making this easier for our teams. So we have to solve a couple of different problems. We have to solve the fact that you have to learn the API each time, right? Is it a REST API? Is it GraphQL? Is there an SDK? There's all these details you have to learn. And then we had this nasty experience where a client asked us to change the rewards provider, for example, in the middle of a project. So if you have SDK calls embedded inside your code, now you have to change that in each place, right? So you're effectively violating the try principle. So this is painful, right? When I'm coding, I like to build well-designed systems that have good architectures where I'm encapsulating my business logic and I'm following solid principles and all that sort of stuff. And what we find is that talking to external APIs and all their strange, weird interfaces breaks that model. So one solution, which we have played around with, right, ChatGPT and all that sort of stuff, and if you were attending some of the talks earlier, you would have learned some interesting stuff there, is, okay, well, we just go to ChatGPT and say, I want to use the Stripe API, just write some code for me. That's kind of useful for getting started. It's definitely useful when you want to do stuff and you're a bit lazy and you don't want to read the docs. It kind of works. So have people done that? Just put up your hand. Have you used ChatGPT to just cheat when it comes to using an API? It is useful, but I find about 25% of the time You say to ChatGPT, solve this specific problem, and ChatGPT will go, oh, here's the API calls, but they're fake, they don't exist. It would be really lovely if they did exist, right? That would be so cool, because you could just solve your problem in one line of code, right? The AI system hallucinates and goes, here's the simple solution, which doesn't actually exist. The other more significant problem, though, is that all it's doing is generating yet more direct SDK calls or API calls that you're embedding inside your system. It doesn't solve the problem of changing providers, doesn't solve the problem of having this large amounts of detail, doesn't provide you with encapsulation. You're just adding more and more stuff into your system. So even though it might be useful for learning purposes and useful to get started, AI is not really a solution to this problem. So in looking at what we were doing, we noticed that most of these API interactions were effectively REST-based, right? Create, read, update operations. And about another 20% of them were what I would call actions. So the CRUD operations are things where you take some entity in the API and you modify it in some way, or you read it, or you list things. The actions are things like if you've used an observability platform or something like Mixpanel, where you're triggering an event, right? It's not really a data entity, it's just a thing that happens once. Or send an email, right? But send mail or something like that. So, being a good software engineer, right, we can apply the Pareto principle, we can go for an 80-20 solution. So if we accept that 80% of our interactions with an API are going to be CRUD-based, then we can just say, well, the API is a database. And it'd be great if we could write code like this, right? So I'm just, at the moment, making this up. And I'm saying, instead of using the GitHub API or SDK, I just want to force GitHub into my database model. And this is an example of using an active record style ORM approach, right? I want to say, create me a repository entity for GitHub, and I want to load it up based on the owner and the repo, set the description, and save it again. And I want all of my API interactions to look like this. I don't care about learning their API. I don't care if they're GraphQL or REST or whatever. One size fits all. I just want to talk to APIs like this. So the solution is really simple. Just, right, in italics, underlined and quoted, just use an object relational mapper. So object relational mappers are slightly controversial. I have a lot of very dear friends who completely refuse to use them. I'm lazy, so I like using them. My SQL is really bad. I get confused about inner and outer joins and all that sort of stuff, so I prefer to stay with one language. But this is my solution. And at this point, I could go home and say, talk done, right? That's the answer. But of course, as you know, it's not quite as simple as that. How? So ORMs are a simple solution in the sense that from the outside, you have a one-size-fits-all interaction, right? It's always the same. There's always an entity of a certain type, like a GitHub repo, or a Trello task, or something like that. And you always perform the same operations, right? And this is just the idea of REST, right? You're just creating entities and reading them and updating them and deleting them. But if we're going to use ORMs to wrap APIs, then it becomes a bit more difficult, right? Has anybody ever looked inside the implementation of an ORM? Like at the code inside Hibernate or Prisma or any of those things? Or inside Django, right? It's a clown show, right? That code is really, really hard. And I'm standing here and I'm telling you that instead of just talking to GitHub directly with the REST API, or instead of calling their wonderful SDK they've already written, you have to go to the effort of wrapping that code, which already works, in custom homemade object relational mappers with your own bad code. Okay, it sounds kind of crazy. But the benefit is, if you have 15 APIs to talk to, then it starts to make sense, because now you interact with everything in the one way. But this whole idea of doing everything in the one way also gives us a solution to the implementation problem of how we make this idea actually work. So I'm going to step to one side for the minute and talk about microservices, because microservices actually provide the solution to wrapping things up in ORMs and making this a lot easier than it sounds. So our abstraction, our one-size-fits-all, rule-the-world hammer is we think of everything as a message. Everything that happens in our system is represented by a message. It doesn't really matter if that's data persistence or API calls or permission modeling or whatever. We don't care, right? It's all just messages. And we take the microservice component model and the way it uses messages and apply it to this SDK wrapper problem. The important thing that I've learned, right, and this is where the gray hair comes in, is that microservices, to be useful, are much better when you think of them as software components and not as lambdas or containers or independently deployable units. And when you stop worrying about the network and the mesh and all that sort of stuff and start thinking about them as software components, they're much, much more useful. So you'll see in some of the discussions and blog posts these days where people talk about modular monoliths. The modular monolith is effectively a load of microservices running together in the same process, right? And we're all hopefully converging on a stronger sense that proper real componentization of systems is fundamentally important. So there's a lot of different characteristics of components. You go to Wikipedia, you'll find a whole bunch. I'm super summarizing here, right? They have to be independent and isolated so they don't affect each other. They should be modular and have well-defined interfaces, right? So that you can plug them together and you know how to talk to them easily. And they should be reusable and replaceable, right? So you can swap one implementation out with another. You can swap one SDK provider, API provider out with another. There's one very important quality of components that I haven't listed here, which is the key to making this work. So let's just explore this to kind of understand this one really important quality. If we think about our software system as components, if we take inspiration from microservices that they talk using messages, then all of our components talk using messages. And I know I'm just repeating Alan Kay from 40 years ago, and this has all been said 1,000 times, right? But it really does work. The most important quality is composition, right? The ability to plug the components together so that you can get bigger components and new ones. And the best example that I've ever seen is still the Unix command line and piping commands together, right? Because you take a command line, piece of command line code, and you pipe the text output into another one, and now you have a slightly more complex program that can do slightly more complex things. It's a really, really simple component model, but because it's simple, it's super effective. This is what we need. If we can get this, then solving all these problems becomes a lot easier. So how do you get composition with microservice/component messages? How do you get this wonderful thing that you fit together like Lego, right? Because that's what we want. You need two qualities. The first one is something I call transport independence. So one of the mistakes that I see in a lot of microservice systems, and even well-designed modular monoliths, is that when you send a message from one component to another, the sender knows who the receiver is. Right? The sender says, I want to send a message to this other component, and the component is named in some way. The component is a network address or the name of a message queue or even a specific function or whatever. But if you can separate the two so that components send messages and receive messages and they don't know who does the sending and who does the receiving, now you've isolated them, now you've made them separate. And that lets you plug them together in new and wonderful ways without breaking the system. The second quality is pattern matching. So how do you get a message from one place to another? You route the message based on the contents of the message. So rather than saying, I want to go to a specific message queue, the system should take a look at the contents of the message and then decide what to do. So let's do a little example of what this would look like. Here's a message which is a JSON object, and it's saving a user profile, right? So, I don't know, person's bio, that type of thing. So this JSON document has a command property, its value is save, it has a name property, which is naming the entity, which is profile, and it has an entity property, which contains the data. So my microservice just sends this. And just because I'm lazy, I don't like lots and lots of JSON syntax, we can do it in an abbreviated form, right? Command save, name profile, entity, whatever. So the way it works is you match up patterns of messages with services. So in my system, if I see a command save property in my JSON document, I send it to the entity service, which knows how to save things. How this pattern matching happens is not important. Maybe you're using Amazon's Event Bridge. Maybe you have a custom sidecar agent that knows how to do it. Maybe you've got some sort of mesh network. Maybe you're just doing it with a switch statement. It doesn't matter. What matters is that the pattern matching lets you change where messages go very easily, and maybe even dynamically. So let's say that we have a new service that handles users. In our MVP, we just had an entity service, and it just knew how to save entities in the system. But now we have some extra business logic to do with users. They might be paid or not, or whatever. And I have two entities. I can save the user themselves when they change their password. I can save their profile when they save their bio. And now I've changed my entity service to be a generic entity service. So if I see command save, it goes to the generic entity service. But if I see command save and name equals profile or name equals user, then it goes to the user service. So the senders of these messages don't know this has happened. They're still sending command save messages. They don't know that there's this new user service with new business logic, because now I'm beyond my MVP and now I'm doing production code. So if you think about it, there's a virtual entity service which is composed of these two more specific services, right? A generic one for entities and a user service just for users. I've composed them together. So pattern matching lets you do this, and lets you do this dynamically. So we're going to use these tools, right, the transport independence and the pattern matching, to solve this too many APIs problem and give us a way to implement object relational mapping on top of APIs. Okay, so this is what it might look like. Right, here's the SDK for GitHub, the way you would just do it normally and directly. And here's where, this is the type of strange stuff that you have to learn, right? In the official GitHub SDK, there are all these like sub namespaces. This one's for repos, there's other ones for projects, there's other ones for users or whatever, right? So you have to learn all this stuff, and it's only specific to GitHub. And then I have an update command, and I pass it the description of my repo, but it's not, there's not one identifier, right? Remember I said there was like weird stuff sometimes? In the GitHub APIs, there isn't an identifier. There isn't like a key to the table. You have to specify two things, the owner and the repo. And I'm setting my description, and I'm saving it. So this is the normal way. So let's represent this as a message, right? We're going to use messages as our one-size-fits-all abstraction. So instead of calling the API, we're going to say, here's a JSON document. Command will save. The name is repo. Now we've added another bit of namespacing. So we've added a base property, which we're going to set to GitHub. Right? This lets us do our pattern matching and be more specific. And then here's the entity, right? The owner and the repo and the description. So we've represented the weirdness of the GitHub API as a message. So you can see how you can do that with any API, right? You can just decide on your own representation. And then we have a GitHub service that does the work of talking to GitHub. And it pattern matches when it sees command save base GitHub. So on a practical level of how you fit your software together as components, you use this pattern matching to make sure that anytime you're trying to talk to GitHub, it goes to the GitHub service. And that applies for all the other APIs you have to talk to, right? If you're trying to talk to Trello or Stripe or whatever, it's the same model. And maybe you don't have a GitHub service. Maybe it's an API service that talks to all of them. That doesn't really matter, right? It's just that you have a structure for composing these different things together. Okay, that's all fun, right? But how do we get to the object relational mapper bit? How do we get to the bit where we have easy-to-use code that we can give to junior engineers who are implementing the business logic? Okay, so we're just going to steal the active record design pattern. Right? If you used Ruby, Django, that type of thing, Hibernate, this is the basic idea, right? Where you create an entity of some kind. So here I'm creating a profile, and this is JavaScript, by the way, because I'm a Node guy, but bear with me. I'm loading up a specific profile based on an ID, making a change and saving it again, right? So the active record model has these standard sets of methods: loading, saving, querying, deleting, that sort of stuff. It's a relatively simple API, and it's always the same, right? So this is one size fits all. And it maps very well to REST APIs and even GraphQL APIs. So we want to talk to the GitHub API the same way, right? So I'm creating a GitHub repo entity, and I'm loading the details of that repo. So underneath in comments, I've shown you what the message looks like, right? Which you've seen already, right? I'm loading, command equals load, base is GitHub, name is profile, here's my query. That's what I want to happen, right? In my code, I say myrepo.load, but then somehow magically that gets transformed by the system into a message that I can send to my GitHub service to do the actual work. Right? And I can do this for all the other APIs as well. So this is what I want the experience of coding against an API to look like. I don't want my developers to learn the details of any specific API or the details of any specific SDK. I just want to say to them, think of it, it's just a database. Here are the entities, here are the fields, job done. And that means that I can give them this unified interface, right? This interface is the same for all of the entities in GitHub API, and it's the same for all the entities in any API that I want to talk to, right? So it's this everything the same, one size fits all. So we're giving our developers a component model, and we're giving them the ability to work with a kind of purified business logic. So if you look at an application, the back end of an application, the code that handles a particular API request, and you look at what's happening, in many applications, there's all sorts of stuff going on. Database accesses, things being put onto message queues, calls to external APIs, also, loading of configuration details, all sorts of weird stuff. But I want my actual business logic to look like this. I don't want to do any of that stuff, right? I just want to work in a simplified world model. I load some entities. I modify them in some way, and I save some entities, and that's all I ever want to do in my business logic. Right? This is easy to understand, and it's easy to test, and it's easy to verify. And I don't want to be dealing with third-party SDKs or any other stuff. I just want to, one size fits all, make the world as simple as possible. So how can we implement this, right? I've kind of skated over the details of here's your ORM, and suddenly there's a message and a microservice that deals with it. You need two things, right? You need to figure out how to represent what our model as an object relational mapper, and then you need to write the code for the messages. So let's deal with the second one first, because that's easier. So here's an ultra-simplified implementation. All I have to do is ensure that when the system sends a message, command save, base GitHub, name repo, this function gets called, right, using my pattern matching, and then I can call the GitHub SDK to do the actual work. So I can ask a senior engineer to implement this. In fact, the senior engineer can implement the first few of these and then pass it to a junior, and they can just fill out the rest. Right, so I've hidden the details of the OctoKit SDK, and I can do the same thing for anybody else that I have to talk to. As an aside, if you think about it, this makes things like unit testing way, way easier. So if you're trying to unit test code that calls third-party SDKs, it's kind of hard, right? Because how do you do it? Maybe you actually literally, I mean, I've done this, you actually literally call the SDKs as part of your unit testing, right? As part of your CI/CD. Sometimes the third-party providers get a little annoyed when you do that. Or you can try to mock the third-party SDK, which is a lot of pain for not much gain. But if it's just messages, it becomes super easy to mock, right? Because you use the same pattern matching mechanism. You just match on some extra parameters, you know, the specific repo, and hard code a response. So mocking becomes much, much easier, and you can unit test code that uses third-party SDKs way easier. Okay, so how do we actually implement the actual ORM? This is the hard bit, right? In software, there's always trade-offs. So this idea that I'm proposing here and this approach is not free. You do have to do some work. If you're using an ORM system already, you're using Hibernate or something like that, and it supports some form of extensibility, then you got lucky, and you can use that. You might be unlucky. You might be using Prisma, which doesn't really have a way to extend the system and access a different database, right? You have to hack it a little bit. You could do what we do, right? Which is we just have our own little thin ORM wrapper over everything, including the database. And that's not particularly hard to do. Object relational mappers mostly just have those simple operations. There's some complications if you want to do relationships, but maybe you shouldn't be doing relationships with ORMs, because that's where they suck, right? You get the n+1 selects problem. Or you don't have an ORM at all. You're a developer that likes to go straight down to SQL or whatever. Fine. Just use the messages directly, right? Represent all of the APIs as messages anyway. This is not totally trivial, but if you are working in an environment where you have multiple clients, where you have multiple projects, you can do this as open source, right? This is very, very reusable code. And it means that everybody in the company gets a jump start on a new project where they have to talk to APIs, because mostly it's been done already. You don't have to send developers to documentation, ask them to read it. This project did it in one way, another project did it in a different way. Now it's all the same for all projects. There is a couple of logistics to think about. So when you're talking to APIs, you do have a whole bunch of setup code where the keys live, all that sort of stuff. I'm not even talking about any of that complexity here, right? But that's just part of the normal stuff that you would have to do anyway. So it doesn't go away, right? Complexity only gets shifted. You will always need a get out of jail option. So this is a one-size-fits-all solution, but it only works 80% of the time. You're going to need to be able, in those 20% of cases, to access the underlying SDK or API. And you're going to have to accept that that's going to have to be part of the code. There are going to be edge cases where the clean ORM-based model breaks down. That's okay, right? You still get it's still an 80-20 benefit. You need to have the ability to recognize that sometimes the model will only work partially. So if you're integrating with Mixpanel and you're sending events, well, the load and delete parts of an ORM don't make any sense. Those methods might exist, but they don't do anything meaningful, right? The only thing you can ever do with a Mixpanel event is save it once. Right? So you're sort of squashing it into a model that's not quite right. But I would argue the benefit is still that it's a unified single model. And another item of logistics, which I haven't mentioned here, but I did mention it earlier, is you do need to have a way to map your messages to the different services. Right? That's another part of buying into this, is you need to have some sort of way to dispatch the messages. But I wouldn't worry about it too much. Right? Even a simple case statement can work and get you quite far. Okay, you might want to see some actual implementation code. This is a microservice framework for Node that it's open source that we've been working on for over a decade now. Has a little community, all that sort of stuff. But if you look at the provider plugins at that link, you'll see there's about 25 of them for different services. And yeah, it's all JavaScript. Some of it is TypeScript, right? So it's proper code. But it'll show you how we've done this and how we solve this problem for a bunch of client projects. And if you look at these, you'll see some of them are only partially implemented because we just didn't need to use various bits of the APIs. But the thing is that when we onboard developers and they have to talk to external APIs, they're up and running straight away because it's just the same as the database. Okay, so let's go back to the one-size-fits-all philosophy side of things, right? So this is driven by a mindset, a mentality, right? Where you're looking at the world, looking at your problem space, and you're going, I'm going to think of everything as a message. And I'm going to think that entity operations are things that I can represent as messages. And that covers my database and a whole bunch of other stuff. And then I'm going to extend that idea to say that API operations are also things I have to deal with. And they're also messages. So I'm going to represent API operations as messages as well. Right? Messages are my representational tool for the system that I'm building. And I guess that is, it's not necessary for that to be universal in your system, but it is an architectural mode that you have to buy into for this to really work. And I suppose as a little inspiration on the philosophical side, this is the Latin version of Occam's razor. I'm sure most of you are familiar with this, right? Don't multiply things beyond necessity. And I find this really inspirational because when I look at API documentation and I look at hundreds of pages of method parameters and all that sort of stuff, and then I have to do that 15 times, it's driving me crazy, right? There are just too many different types of things in the system. There's too many things to think about. I want to find some unifying principle to simplify it and make it easy for me to comprehend. And it's not just the case that you have a unifying principle, right? That's not good enough by itself. It has to be a useful and good principle. So the example I would use is something like Ptolemaic astronomy, right, which had a unifying principle, right? Everything is just going around the Earth in circles. But then that doesn't match up with actual observed planetary movements, so then you have to put circles on top of circles, right, the epicycles, to explain what you're actually seeing in the heavens. And it starts to get really complicated because there's cycles upon cycles. But it kind of works. That was a unifying principle that worked for, I don't know, 2,000 years, something like that. And then Newton comes along and comes up with a better unifying principle, right? Newtonian mechanics. And that explains a whole bunch of stuff, except, of course, the orbit of Mercury doesn't quite work, and a few other things. But the Ptolemaic astronomy was not thrown out just because it had aberrations and was a bit annoying to use. And the same way, Newtonian mechanics in astronomy wasn't thrown out, despite the fact that it nearly worked, but didn't quite work. I won't give you the details because they're hard to remember. But when Einstein came along, right, with relativity, in the early days of relativity, there were more unexplained aberrations in astronomical observation than there was in Newtonian mechanics. And they were sorted out over time, right, as people had better experimental methods and that sort of stuff. But Einstein's relativity was accepted and allowed us to move beyond Newton because it was a better unifying principle. People could see that you could use it more effectively. So hopefully that's a bit of inspiration for having unifying principles in software, right? Can we reduce the number of things that we have to learn? To use a software example, if you think about classic object-oriented programming, the promise of objects didn't really work out. They didn't really give us components. And part of the reason for that, I think, is because object-oriented code has too much stuff, right? You have inheritance and polymorphism and all sorts of stuff, static members. There's too many things, right? The unifying principle isn't simple enough. I think that the idea of using messages for everything and a component model where you have a couple of simple rules for composing the components together does give you a simpler way to build software. And I've been using it to build business logic for a while and then microservices, and it does keep on giving. And I guess the point of this talk is, now that we've applied it to a new problem, which is the proliferation of all of these external APIs that you have to talk to in any modern system, it has yet again proven its worth. The only downside is it's a pretty weird programming model itself, right? You have to kind of get used to it. So I guess my final point is that if you're trying to talk to a lot of APIs, they have the same hairiness that classical object-oriented code has, and that there's just too many things, there's too much stuff, right? Too much accidental complexity. And to contain it, I think that justifies taking a hammer and looking at everything as a nail in 80% of the cases, because I think that's still a win. Okay, there is a book to explain a lot of this in more detail and kind of back up a lot of the claims and statements and all that sort of stuff. But that is pretty much it. Thank you very much.
Thank you very much, Richard. Inspiring. Let's see if we have questions in the audience. And as usual, it will take a couple of minutes for the audience to build up the questions. So I will take advantage of that, and I will ask a couple of questions myself. So this model, which works like almost like a message bus, right? The framework that you have been building, is introducing this abstraction, which is making it really easy to fire messages and almost forget. But I'm assuming it also has ways to receive response and handle it and things like that, right?
Yes.
Okay.
Yes.
But I think it introduces this simplicity, which I like, but isn't this also taking away from us as developers nice capability that we have when we use different kind of abstractions like interfaces and dependency injection so that we can take advantage of auto-completion and typing and this sort of thing. So you're introducing a new type of abstraction when we already have interfaces and DI. So why will we go for this rather than also?
Okay, yes. So the critical thing is this abstraction and this method is for boring business logic code, shopping carts, that type of stuff. The abstractions you're talking about are for nice code, like proper algorithms, right? Implementing linked lists, right? Implementing Raft, implementing AI systems and transformers and all that sort of stuff. There's different types of coding, right? There's this business logic stuff for shopping carts and processing transactions. There's the computer science piece. There's kind of framework infrastructural code. So this abstraction, and I guess that is a good point, and I caveat that I didn't put in the slides. This abstraction is for business logic. It's only for that domain. It's not universal for all coding.
Okay, let's see if
over
we
here.
have questions. Yes, okay.
Yeah, GPN kind of stole half of my question, so I have to rephrase it now.
Sorry, buddy.
Yeah, my question is, this is like a really interesting way of abstraction and a bunch of APIs underneath. What are other ways of abstraction do you kind of tried before this? I don't think it's the very first idea that you came with, right?
No. So in terms of my personal journey, I started coding Perl CGI scripts, right, to implement contact forms on websites, and eventually discovered Java and discovered, the Gang of Four design patterns book, and I memorized all of them, right, visitors, all that stuff, right, and used that classical object-oriented approach for a number of years quite successfully. But then I hit a number of issues. So I ended up working in the telecom sector implementing SIP servers, right? So this is like voice over IP telephony protocols. And they had this problem where you have these inbound messages that look like HTTP GET requests, except they're much more complicated. There's loads of other things that happen. There's loads of state management, if you think about a phone call. And that's where the idea of this pattern matching on messages I started finding that useful. And then I reapplied that to more ordinary business logic, where I was using kind of a command pattern, even for things like building shopping carts, that sort of stuff. But I was still building monoliths. So I suppose the natural journey ends up in a place where I'm very heavily leaning into messages as an abstraction to handle, again, business logic style code. I don't reject other types of abstraction or functional programming or any of that sort of stuff. It's just that for the specific constraints of commercial business logic style code development, where things are never perfect and their client is changing the requirements all the time, I find this to be a good abstraction.
Okay, we have one more question there. Until the microphone gets there, one question from me. Since you talked about getting this e-commerce kind of integrations, I know that especially when it comes to payments and shipping and other things, usually the integration comes along with a different workflow from provider to provider. So it's not like you make an API call and you get the response and you're done, but you actually get maybe a token and you redirect the user, and the user is taken to some provider landing page, they fill in some information, and 5 redirects later, they get back to your website. So that workflow might be different from implementation to implementation. And while you're abstracting this really nicely with the messages, how are you coping with that scenario in your framework? Or is this something that you just leave it for the 20% get out of jail card that you kind of have in the system?
Mostly, yes. So there's a couple of different strategies. One is you wrap that up in a fairly large microservice, and it's normal code. It's not the messages stuff. But if you're doing it for a couple of different, if you've done it for a couple of different projects, you'll start to see the similarities. So you can start representing some of the activities using messages, and then have to get out of jail for some of them. But the particular scenario that you mentioned there is only a 20% scenario, because a lot of the time, the external API. So one of the ones we did was an encryption service where you're asking for certain data to be encrypted, and that's just a request response. And if you change provider, it's always going to be a request response model. So often it's not quite as complex.
Okay, thank you. Let's see the question that we have there.
Much. Okay. So as you said, you are not exactly fixing complexity, you're just rather shifting it to the right, let's say. So that's where I try to get with my point. I feel like this isn't really solving a problem, it's just introducing another layer, but you still have to deal with the underlying issue, which was like badly documented APIs or SDKs or whatever. So someone still has to take care of the job.
Yes, yes. This approach makes more sense in an agency setting where you're going to be doing multiple client projects, because then you can get the benefits again and again. If you were building a SaaS startup, I wouldn't recommend doing this unless you were already using a pre-packaged open source solution, because you're only going to be building one system anyway. But if you have to do this again and again, then it justifies the investment in the senior and architect level people in the organization encoding some of their knowledge of the APIs in a simple package for the more junior people. So it's more of a commercial argument than a software argument.
So in other words, only if you have many APIs that you integrate and maybe different combinations over time, so rather than you define your own, almost like a DSL to integrate anything.
Exactly.
And then behind the scene, you abstract away the complexity.
Yeah.
Okay, other questions? Okay, I'll go next then, since we have some more time. So I'm curious if your entire, let's say, schema validation, since you mentioned active record, right? So or persistence layer kind of things. If anything that goes into validation, into structure and things like that goes into that, let's say, repository implementation. Or do you have, like, some of the languages have maybe something that enables you to have, like, I don't know, an entity, a model object, and then through, I don't know, some sort of annotations or decorators in TypeScript to have those automatically identified, and then the system works just like that?
A totally different talk.
Okay.
So if you have entities in your system and you have some sort of schema validation of any, and some sort of description, and maybe you're generating it from the data definition languages, maybe you have, I don't know, you're using Zod in TypeScript and you're defining them separately. You should be doing that. Mostly it's done for database entities, but there's no reason why you can't apply the same approach to the API stuff as well. Yeah. So you get your own validation. It depends on the context whether that makes sense, right? Because the third-party API is going to do stuff for you. But you would be surprised how badly third-party APIs validate data if you integrate with a lot of them. So it's worth doing. But this is where the one-size-fits-all idea comes in, right? Because now you just have schemas for everything. And is an entity a database or an API one? It doesn't really matter.
Okay, thank you. We have some questions there. Can we get a microphone, please? Over there, on the right.
Hi. We're currently building a similar system for one of our platforms, but this is mostly focused on events. So we use messages to trigger different events on different actions. My question is, how do you implement the parity? So for example, an API adds a new feature or another endpoint. Do you usually implement that feature as a new message or a new action that is handled by this orchestration? Or do you integrate it in other messages?
If it's a new endpoint, it's usually a new entity. So GitHub, right? So you would have had normal, GitHub is a good example because you would have had repos and stuff, and then they added projects, and then they added actions. Those are new entities, so those would be new messages, and you'd have to implement them again. I'd say that's more what would happen than extending existing messages.
Okay, thank you.
So the way that I see this, in what you were saying, you end up having like this sort of central event scheduler or so. How do you end up not hitting a bottleneck? Like let's say you have a huge business application and you have a lot of hits. How do you end up not bottlenecking with the event scheduler because you have a lot of things going everywhere?
Okay. Okay. So the trick is to make sure that you are building a modular monolith as well. So when I say the message goes from one microservice to another, maybe it's going over a message queue or event bridge or something like that. It's very important that that is an abstraction. I don't know, maybe some of you might have seen recently Amazon Prime went from a microservices system to a monolith because the microservices system turned out not to be very efficient. If you're strict about having an abstraction around how messages get from A to B, that's why the transport independence principle is there, then you can, when you end up with a bottleneck, and often you discover them in production, right? You might have this like widely distributed system, it works as an MVP, and then the load goes up and now you have problems. But if you've designed it with this abstraction, you take two microservices and put them together, turn them into a macro service. And maybe like Amazon Prime, you turned it into a monolith in the end. But at least you've got a component-based system. And because you forced yourself to do it over the network at the start, you've really strictly enforced the fact that it is components, and those interdependencies don't exist. So yeah, function calls. Just reduce it to in-process function calls. That's the solution in the end.
I think we had one more question there. Yes.
I was wondering if you implemented the pipe thingy, communication between so piping the services, the requests, synchronous, asynchronous, and how did you do it? The Linux example you gave.
So if I understand correctly, you're asking how we handle different types of messages, ones that are synchronous and asynchronous.
No, if you're able to chain the service call similarly to the piping in Unix.
Oh, yes. But I wouldn't recommend doing very much of it because you end up with, a request might come in and then you're bouncing across different microservices and each one is introducing latency. If you end up with a structure like that, then like the previous question, you should put them together. Generally, I kind of cover this in the book. Generally, there's different patterns that emerge where a triggering message either causes a chain of messages, and they're all synchronous and they're all request response, so it bounces down to the end and then bounces back up. Or you have a scenario where it's asynchronous and one message comes in, it fires off a bunch of asynchronous requests, and then depending on your business logic, you might get some responses that you aggregate and send back. If you look up a guy called Fred George, who did some of the early work on microservices. He talks about a scenario where he was building a system that was doing insurance quotes based on a whole bunch of criteria of the user. And they would have different microservices that would generate different types of quotes, but they'd have a timeout of 200 milliseconds, and if you didn't get your quote back in, it wouldn't go to the aggregation. So there's a whole bunch of different patterns of the way you put them together.
But I think most commonly in the API world or in the microservice world, choreography is what people do usually
Yes.
to do this sort of the communication between services, unlike orchestration when you have a central piece that distributes it, right?
I mean, ultimately you end up with an enterprise service bus, right? So MuleSoft just keeps making money.
Okay. Other questions? Okay. Maybe we'll give them a bit of time to analyze and process what was discussed so far and come up with new questions. Up till that point, do you plan any updates on your book, maybe with what was developed on the market ever since?
Yes. There's the second edition coming out.
Cool.
So that covers a topic. I said it was another talk, the schemas. So totally separate from this talk, completely different subject. One of the things that we found useful for controlling these types of systems is having a type-safe, model-driven architecture. So if you go back 20 years ago when people were writing UML and Rational Rows was trying to generate code and was horrible and it was a really bad experience and it didn't work, what we're finding is that if you apply modern type safety and those types of ideas and you stay in code, you can do code generation and you can do system validation and schema validation in a really nice way. There is a language that I use for that called Qlang, CUELANG.org. It's written in Go. And it's written as a configuration language, right? So it's kind of like Terraform, that type of stuff, but it can be repurposed. And it doesn't use inheritance. It uses composition, which is why I like it. So yeah, totally different topic, but take a look at that. It's really cool.
The developers next year. We have a question there.
Yeah, hi. Thanks for the presentation. I was wondering if there would be a unified, let's say, way of calling the APIs. Like all of the APIs would adhere to the same specification.
Yeah, that would be wonderful. I mean, as an industry, that's what's actually needed, right? You have all these different service providers, thousands and thousands of them. Part of the motivation for this is that we are starting to integrate with companies that are not technology companies, right? Software is eating the world. These are companies that are starting to have to offer their own APIs, but they're not technology companies, so they do all sorts of crazy things. I mean, you do have Swagger and things like that, but it only sort of solves 20% of the problem. I think, I don't know, come back in 10 years, 20 years when there's been enough pain, there might be an industry-wide actual standard, but you'd need to be patient.
Yeah, well, I was thinking at JSON API, maybe that specification or something like that.
Yeah. Sorry, say that again?
I was thinking at JSON API specification or something like that, if it would be universally used.
Yeah, it would be fantastic. Mm-hmm. It would be fantastic, but service providers just cannot resist the temptation to do interesting things. That's the problem.
As soon as we got away from SOAP, which
right,
was
yeah.
forcing us, nobody wants to go back to something like that, right?
Yeah.
Okay, any more questions? I think we're getting warmed up, right?
I will say, just go back to one thing, which is the unit testing.
Yep.
So, and the reason I put that slide in there as an aside is not by design and not deliberately. This is more of a discovered fact, an empirical fact. Mocking is really hard, but when you're just mocking using messages, right? And mocking using a message is, I see these JSON properties, and I give you back this other JSON document. And that's your mocking. That solves a whole bunch of problems, because you don't have to use mocking libraries. You don't have to worry when versions change or whatever. It's super easy to see the business logic. It's super easy to see what's happening. We've even got to the point with a lot of unit tests where the unit tests are specified as JSON documents, right? I give you this JSON, this is what you give me back. So the unit testing code becomes a lot easier to write. It's an unexpected side benefit. But I suppose that's what happens when you have a one-size-fits-all, right? When you try to unify the world, you do get certain efficiencies. So I'd say that's one of the bigger benefits.
Not sure if you have already considered this or if you guys are already doing this, but speaking of collateral benefits or collateral damage, I think there is a lot of opportunity into an approach like this to introduce a concept such as, I don't know, middleware, where you can either log everything that's happening and understand a bit the interaction with the third parties, or even add Prometheus metrics and figure out when services degrading or things like that, right?
So that's what we're going to build next, actually. So observability is really, really useful. We one integration that we did was with open banking APIs. So because of the European Union, all the banks have to have proper APIs now. But their implementations they're not even normally distributed in terms of good and bad. They're skewed. Most of them are bad. And you get weird latency spikes and all sorts of stuff. But the problem is, for our clients coming to us, all that they see is, oh, my user tried to use the app and it didn't work. Or the app is slow, right? And the underlying cause is that the banking API or the third-party API is flaky or unreliable, or it's always slow at 10 o'clock in the morning because they're running a batch job. That's real, by the way. 10 a.m. and 10 p.m. on one API, calls fail for 5 minutes, right? Now, we only know that because we're looking at Lambda logs, right? It'd be really cool to use the fact that everything goes through the one software abstraction to have much more observability. So that's what we're building next.
Awesome.
It is really cool. Yeah.
Awesome. Okay, waiting for some more questions. We still have 5 minutes. So, other than what you're describing in the next chapters of the revision of the book, what significant development have you noticed in the, let's say, ecosystem, in the landscape of API, cloud computing that was making you say, wish I had this like 10 years ago? What was the, or maybe some biggest leaps forward in terms of
serverless,
APIs?
Serverless. Serverless is absolutely right. So, I sort of deploying things to bare metal, running VMs, running containers, did container-based systems for a long time. Ran Kubernetes, right? Big Kubernetes system, over 100 services, all sorts of fun stuff. The trade-offs with serverless, right? And Lambdas and Google functions and Azure functions, they suck, right? They have a lot of really nasty failings. But the operational simplicity, Cloudflare edge functions, all that sort of stuff, all of the negatives and all of the pain and all of the problems and all of the ways that you have to change your software to work in a serverless context, it's all worth it because it just makes... I suppose it's another example of this principle, right, where you're just squashing everything into one way to do things. But it just makes the operational side so much easier. And yes, you have clients phoning you going, it's slow, and you're trying to say, well, there's this cold start thing, and cold starts suck, but it's still worth it. It's still just made the cost of running and deploying an application so much easier. I just never, ever worry that the system is going to go down at the weekend.
Maybe
it
it
doesn't happen.
Still goes into that 80% kind of thing, right?
Yeah,
even
exactly.
if that doesn't solve all the problems.
Yeah. I mean, I know that's kind of a cheesy answer, but yeah, serverless is cool.
Okay. Thank you very much, Richard. Unless we have a last question from the audience, I guess we can definitely thank Rodger with a big round of applause for the amazing presentation.
Thank you. Thanks.
And hopefully, we're going to see you again here with the book review
I have
and
to now,
the
but
new,
I have
the new
to.
topics.
Thank you so
Okay.
much.
Thank you. We are now...